Chapter 2. Chapter 2, I'm going to start out with something that looks like this. Okay. I have a line segment. I have the origin 0, 0, and it goes all the way out to 4, 3. And there's two things we're going to be talking about early on in this section. And the first is, how long is that? How long is that? Well, some of you are going to say, yeah, I remember the Pythagorean theorem. And that's x squared plus y squared equals r squared. And I kind of remember drawing a triangle like that. That is a right triangle. And this length is 4, and this length is 3. And I'm going to call this guy out here R. So now I'm going to use the formula for a right triangle that says x squared plus y squared equals r squared. So I'm going to say x squared plus y squared equals r squared. Now x squared is this length, 1, 2, 3, 4. I don't know why I get so turned around. I go this way, so I want this to go this way. There we go. Okay, so now I'm looking at 4 squared plus 3 squared. Did anybody get excited when I say 4 squared? And they're like, oh, I remember in elementary school in the playground, we used to play 4 square or something. No? Yeah, some of you do. 16 plus 9 equals r squared. 25 equals r squared. R equals 5. And we're like, okay, cool. Yeah. That's even known as something called a Pythagorean triple, which some of you may have remembered. The 3, 4, 5. Contractors use this. They want to make sure this is square. They'll measure two boards together. They'll measure over 4 inches. They'll measure up 3 inches. And then when they have these 2 points, and when this is a 5, they know that has to be square. Yeah. Okay. Well, what about this guy? What's his distance? First of all, the point is 1, 1, 2, 3, 4. So that's 1, 4, 1, 2, 3, 4, 5, 6, 1. And I know some of you are drawing that, so I'll give you a second. And let's see if I draw the triangle here. It's not really on the axes. It's sort of floating up there. But what is the length here? Well, I'm sorry. Let's do our x first. Let's be consistent. How far is it from here? Actually, it should be a little wider because from 1, because this one right here is at 1, from 1 all the way out to 6. How long is that guy?
5.
Yeah, he's 5. Okay. And I have the 1 and the 6 there. And wait, okay, check this out. Remember I had my x before and I squared it. I'm thinking that I could do something like, okay, oh yeah, this is that 1 minus 6 squared, because it's going to give me a positive. And then for my y's, I went from 1 up to 4, 1 up to 4. So that guy was 3. And I kind of got that by doing 4 minus 1 equals r squared. So this was 5. This was 3. And I took the 1 minus the x and the y minus the y to get those lengths. Doesn't matter if it's negative because I'm going to square it right away. That's going to bail me out. So now if I took this bad boy and went, brought the square root over right now, I'd be able to find r. And this is that 1 minus 6 squared plus 4 minus 1 squared. And all of a sudden, I'm going to say to you, this is the first important thing we're doing today, and that is the square root of the difference in x's. I'm going to call one of them x1, one of them x2, plus the difference in the y's, y1 minus y2. Remember, I'm squaring them because when I did the Pythagorean theorem up top, it was x squared plus y squared equals r squared. I brought that square over. Well, what does this formula now give me? Instead of r, I'm going to say, yeah, I don't want the r between the 2 points, but I'd like to have the distance between 2 points. And that's where the old distance formula comes from. Comes from the Pythagorean theorem. I took the r squared, I brought the square over. This was the length of the x, and then I squared it, plus this was the length of the y, and I squared it. Okay. So that's the first important part of today. The second important part is, what if I took that graph up here again, 1, 4, and 6, 1, and I said, what's the middle of that? What's the halfway point? What's the, and some of you, yeah, it's called the midpoint. Oh, why am I writing down there? You can't see it. It's called the midpoint. Okay. How do I find the midpoint? Well, if I gave you two numbers on a number line, like so, and I said 2 and 8, what's the midpoint of 2 and 8? What's right here? Not really the point. What's in the middle of 2 and 8? Well, how far is it from 2 to 8? Yeah, we have a 4. Well, wait a minute. If I go
5.
1, 2, 5, yeah, I think it's going to be 5. Now, mathematically, we'd like to be able to get that 5 somehow. We'd like to be able to get the 5. And the way I get that point in the middle is I find the average of these two. What's the average? Add them together and divide by 2. 2 plus 8 is 10. Divide by 2. So when I want to find the midpoint, you know, I'm going midpoint. Wait, that's the average. That's the average. So the midpoint up here is going to be 1 plus 6 divided by 2. Oh yeah, this is a point. 4 plus 1 divided by 2. So I want the midpoint, not a number like the slope. I want a point. What's the point in the middle? It's the average. Okay, looks like it's going to be 7 halves, comma 5 halves. If I went up here 7 halves, 1, 2, 3 and a half, 5 halves, 1, 2 and a half. Boom, I got it. I got it. So the second important thing is the midpoint. Okay. And these are building blocks, and we're going to use these hopefully over and over and over. And you'll say, oh, I need a formula sheet. Now, you might want to make a formula sheet now, but for the test, when we do the test for chapter 2, hopefully you will have used these enough times that they're going like, yeah, I know the distance formula. Yeah, I know what the midpoint is, average, but it's a point. Let's see what we got. We have lecture notes for section 2.1. Yeah, oh boy. Plot each point. I think we're okay with that. We don't really need to work on plotting each point. But let's come down here and find the distance. Number 2, let's do the distance between those two. And remember, again, it was how far apart were the x's? I squared them, plus how far apart were the y's? And I squared them. Oh, -3 minus 3 squared, because remember it was that x squared, plus y minus y squared. Let's limbo a little lower now. Boy, oh boy, oh boy, -6 squared plus -4 squared. Oh, that's not 4, that's 16, you dummy. Equals the square root of 52. I think I can make this the square root of 4 times 13. What do you think about that? Got the basic idea?
Yeah.
Okay. Does anybody want to do another one? Number 3 is available. Number 4 is available. Or do you think you got it? Number 4 is hard because you're squaring binomials and all kind of crazy stuff in there. You good? All right, well, let's move on. Distance formula is really a matter of knowing the formula. All right, determine if the given points form the vertices of a right triangle. Huh. I'm going to graph it first. -2 and 1. +2 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, +2. How would I know for sure this is the right triangle? If the one leg squared plus the other leg squared equal the hypotenuse squared. So now I need to find the distance between these 2 points, the distance between these 2 points, the distance between those 2 points. Oh. Let's take a look at AB first. That's going to be the square root of x minus x plus y minus y. That becomes -4. And when I square it, I get 16. This becomes -4. When I square it, I get 16. That's the square root of 32. I'm going to leave it like that for right now. We need to calculate AC. We need to calculate BC. Oh man, AC/DC, man, rock on. Oh, sorry. That was before most of you were born. AC, the square root of -2 minus 5 squared plus 1 minus 2. How in the heck do I get so turned around? Please, somebody tell me you have the square root of 50. Anybody?
5 root 10. I don't know if that's wrong.
I'm going to leave it like this.
Okay.
Yeah, but I know what you're saying. That would be actually 25 times 2. So
5 root 2 then.
yeah, 5 root 2. Yeah. I'm gonna leave it like that for now. I have a trick up my sleeve. X minus X plus Y minus Y. Good thing about this problem is the repetition. It's like doing push-ups to get ready for a football game. You know, you have to build the muscles so you can do well in the game. -3 squared is 9, plus 9 equals the square root of 18. All right, so I think my long side is AC. So when I did the Pythagorean theorem, I said take one leg, square root of 32, and square it, plus the other leg, square root of 18 squared, and that has to equal the hypotenuse, square root of 50 squared. Square root of 32 squared. Oh, now I see the method to his madness. Ba-boom. Ba-boom. Leg squared plus leg squared equaled hypotenuse squared. Sneaky old man. Cool. Oh, they want us to find the midpoint. Find the midpoint, average. So we need to find the midpoint, average between these 2 points. And when you find the average, you add 2 numbers together and divide by 2. -1.8 plus 4.5 divided by 2, comma, -3 plus -1 divided by 2 equals the ordered pair. I'll do this one. Second number is -2. Sorry. This guy becomes 2.7 over 2. If I cut that in half, I get 1.35, comma, -2. Final answer, Alex. Good. Graph the equation by picking points. Well, I'm looking at the graph down here. Yeah, some good stuff's going on. I'm going to pick these points for X, -2, -1, 0, 1, and 2. And if I plug those values in, pick the points and graph it, this is, yeah, this is one of my quadratics. Quad being 4, which I don't know why it's a squared because it, oh, geez. And I know that this a quadratic is going to have a U shape, either U shape up or U shape down. Remember, we shot the arrow in the air and it went up and it came right back down. Start plug points in. -2, if I plug it in, I get -2, 1, 2, 1, 2, 3, 4, 5, 6, 7. Shaka Khan. -1, 4, 1, 2, 3, 4. Boom, boom, Boom. Ah, this guy has symmetry. Symmetrical. Symmetry over y-axis. Did you hear me drop my pencil after I finished it? I'm like, bam, I'm out. Bam, I'm out. Okay, picking points, easy way to graph. Eventually, we're going to learn that, oh, I have a quadratic, and then that +3 gives me this whole, oh, look, it moved me up 3 kind of deal. We'll start to get a sense for how to do these quicker than having to just pick points. Oh boy. So what we're getting into is a group of things called parent functions. Parent functions. And y equal x squared is a parent function. Y equals the square root of x that we're going to look at next is a parent function. Y equals the absolute value of x is a parent function. We're going to learn what their generic shapes are. And I already know from my experience what this guy is going to look like. Well, first of all, what numbers can't I put in there? Well, I know oh boy, in the world of square roots, I can't have the square root of a negative. So 0 can go in, -1, -2, -3 can even go in. -4 cannot go in. X cannot be less than, it cannot be less than -3 because I get an error, I get imaginary stuff. So I can't be, so my ordered pairs this time, -3, -2, -1, 0. I'm going to put those in. And some of them are going to be nice and I'll keep them. And some of them won't. If I plug negative, okay. If I plug -3 in, I need an answer.
0.
0, good. If I plug -2 in, what do I get?
1.
1, good. If I plug -1 in, I get that, and I don't want to graph that. If I plug in 0, I get that. I really don't want to graph that. What if I plug in 1?
2.
Yeah, I like that one as well. So I'm going to come over 1, 2, 3. There's my first point. There's my second point. There's my third point. And the graph is going to look like this. So that's, again, one of my parent functions. It's always going to have that shape of a starting point and going over. So on this next one, of course, they decide they want to mess with you. And since I have x alone on one side, this time I'm going to pick values for y and then solve to see what x is. Let's do some of our favorites. -2, -1, 0, 1, and 2. I got a 6. I got rice cooking in the microwave. When I put 0 in for y, x is 4. I put 1 in for y, x is 3. When I put 2 in, I get 2. 6, -2, 5, -1, 4, 0. 3 is 1. 2 is 2. Geez. Looks like it's almost a line, but I know it's not. I'm gonna keep going. I'm gonna put, let's see, I'm gonna put 4 in for y. And I get 0 for x. 1, 2, 3, 4. I'm gonna go one more. So I'm gonna keep going because I know the absolute value is always going to be a V shape. So if I put -1 in for y, man, this is just crazy. -1 is 5 and -2 is, okay, wait a minute. If I put -1 in, that gives me 5. Oh, I already did that one. At some point, something crazy is going to happen. This was an awful example for them to start with, because it's starting to look like it's that kind of shape, a linear shape. But at some point, this becomes a V. They should have done this. Y equals the absolute value of x minus 2 to get you up and started, because the graph of that is going to look something like this. And I just know that from experience. Yeah. Okay. Bad example. Bad example, bro. We're not going to do number 10 because I don't like that example either. Terminology. Terminology. Identify the x and y axis or intercepts. Intercepts. Here's an intercept. There's one. There's one. There's one. Okay. The intercepts are where they touch the axis. Oh, hey, hi, Jandy. You came in late. I didn't even see you. Emma, did you make it? No, Emma. The x-intercepts. Where does it intercept? 3. 1, 2, 3. Oh, these are easy questions. Hope they're on the test. The x-intercepts, -2 and 2. I'm allowed to have more than one. Y-intercept, -4. So the intercepts are going to be where they touch the axis. Now, when I talk about this x-intercept, it's at the point 3, 0. Over here, this is at the point 0, 5. 2, 0. 0, -4. -2, 0. Okay, I'm seeing lots of zeros with my intercepts. So an x-intercept, the y is 0. And a y-intercept, the x is 0. So that basically comes from, if I say to you, find the intercepts, I'm asking you to do this. I'm asking you to do this. If I put 0 in for x, what's y?
Nine.
9. If I say put 0 in for y, 0 minus x squared equals 9. X squared equals -9. X equals plus or minus the square root of x equals plus or minus 3i. And we'll talk later why those imaginaries come into play and what all that means. So we don't have to worry about that right now. We're worrying about how you find intercepts. Again, this is just another piece of building blocks for later. Anybody have answers for 14? If I put 0 in for X, I'm done. If I put 0 in for X, because this becomes equals -2, can't do that. Nope, can't do that. If I put 0 in for Y, X equals 5. So I have an X-intercept, Y-intercepts are no. No good, no soup for you. Do-do. Do-do-do-do. Do-do-do-do-do. All right, so that's going to bring us to the end of 2.1. Some of you are really like into calculators and all of that. So here's some things that you can do if you want. Graphing equations with a graphing calculator. I'm not going to cover it, but it's there for you if you want to check it out. Funk Soul Brothers. And there's a whole nother page of that. All right, we got through it. We got through that. Oh boy. Any questions on section 2.1?
Nope.
Nope.
I have a question.
Yes.
So while plotting in the x and x values for the absolute graphs, we don't have to worry about the plus minus there, because always we're gonna get two values for y if it is the absolute value equation, right?
Okay, let's take a look at another one because I didn't like the one that's in the notes.
Okay.
Y equals the absolute value of X minus 1.
Yes.
Let's see what that graph looks like. So as we just learned, we're going to pick points. And we just talked about, well, I'm going to do maybe like -2, -1, 0, 1, and 2. But one of the other things I now might want to check out is, what if I throw a 0 in for Y? Kind of deal. All right, so we're going to start to take a look at 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. I'm very good at counting to 4, aren't I? If I plug in -2, -2 minus 1 is -3. The absolute value of that is 3. If I plug in -1, I get the absolute value of -2, which is 2. If I plug in 0, looks like 1. If I plug in 1, it's 0. Uh-oh, here we go. That took care of that for me. If I plug in 2, I'm at 1. If I was to plug in 3, I'm at 2. Ah, -2, +3, -1, +2, 0, 1, 1, 0, 2, 1, 3, 2. So now I see, yeah, this is what the absolute value is going to look like, a V shape. Why they mixed up the X and the Y, that's on that example. I'm going to have to change it. Don't like it. But now you can see what an absolute value shape looks like. It's always going to be a V shape.
Okay.
Okay.
Yeah,
So,
yeah. My question was like, when we solve for y, so we plug in x -2, right? If you saw
yeah,
that paper,
yeah,
so we should get y is equal to like negative and positive values for 2
right. Yes,
for
you're absolutely
y.
right.
Yeah.
You're absolutely
So are we going to write down both negative and positive values, or are we just going to write down just one value?
you should write down 2,
Okay.
and that's where that would have changed the problem we were working on.
Okay.
But at this time, we should have just like, no, don't do that kind of deal.
All right.
Good questions. Other questions? All right, well, let's see what we can do with chapter 2, section 2, and get started. And the first thing I do is I notice that Seems a little bit like we're jumping all over the place. We're looking at graphs of parabolas, then we're looking at graphs of absolute values. And, we go, oh boy, we're just kind of here and there. Well, we're now going to take a look at circles. And you can kind of see where this looks a little bit familiar. Almost looks like that distance formula put together kind of deal, and so on and so on. And in a way, there is a direct relationship. So here is what's called the standard form of the equation of a circle. X minus h squared plus y minus k. And the h will always go with the x because it's horizontal, right? X is horizontal, h is horizontal. K goes with y, and it's not critical, it's vertical, but so you always see that relationship. Just tuck that away. All right, so here's an equation of a circle. Here's the equation of a circle. And this circle is going to be, again, x minus h. This is x minus what? This is the same as x minus -3 plus y minus 2, 4 squared. So you see where the first value is -3, the second value is 2, and that's going to be the center for my circle. The radius is what we get out of here. It's going to be the square root of that number on the end. In this case, it's just 4. So now I have a circle at -3, 2, and then I go 1, 2, 3, 4 that way, 1, 2, 3, 4 that way, 1, 2, 3, 4 that way, 1, 2, 3, 4 that way. And then you see I drew a perfect circle there, didn't I? No, maybe not so much. All right. Well, is that enough for us to draw a perfect circle? Oh boy. 0, -3. Okay, I'm going 0 left and right. I'm going down 3. I'm going down. I'm yelling timber. That's my center. My radius is 2. So I'm going to go 2 that way, 2 that way, 2 that way, and 2 that way. So this circle, right, represented this way, oh boy, is going to be a perfect circle like this. Hey, that's not too shabby, is it? What would the equation be? Well, it's going to be x minus 0 squared plus y minus -3 squared plus, or what we actually equals 2 squared. I'm going to clean that up. X squared plus y plus 3 squared equals 4. And this is something we're going to learn how to do. We're going this direction, given the center and radius, come up with the equation and be able to graph it like we just did. And then eventually we're going to say, here's an equation. Can you graph that circle? So instead of going from here to there, we're going to be going backwards. That's the hard part. I like it though. That drawing, it should be pretty easy. The equation is going to be x minus 4 squared plus y minus 3 squared equals 3 squared, 9. All right. And we don't need to do many of these because when we go backwards, it's going to be a little bit different. Okay, so there's the equation of a circle. And this is what we're going to do most of the time. Why it needs to be written in a general form, I don't know. But how would we do the general form? Well, we're going to walk through this. We're going to say this is x plus 8 times x plus 8 plus y minus 1 times y minus 1. Because this is going to help us, like I said a little while ago, when we're given it in this form down here at the bottom, like where we're going to end up, we're going to be given this. We need to be able to graph the square. So we're going to say, oh, let's take a look at these steps and go backwards. X squared plus 16x plus 64. I hope you've had plenty of practice foiling, or I say double distribute. Y squared minus 2y plus 1. And it looks like they want us to write this as x squared plus y squared plus 16x minus 2y. 64 and 1 is 65. And then we want it to go to 0. Okay, I'll play the game. X squared plus y squared plus 16x minus 2y. And when I subtract that, I still have 40 left. Now the good part. Now the good part. Completing the square. Okay. If I have, for example, x plus 8 squared. Okay, we know that that is x plus 8 times x plus 8. If I do the first, it's x squared. If I do the outer plus the inner, it's 16x. And then the last is 64. You're going, great, I know how to do that. Well, now we're going to learn how to complete the square again, which is something we saw back when we had the quadratic formula. We were solving quadratics by completing the square. We're bringing that back. I'm bringing booty back. If I have x squared plus 8x, what would I need to add to make that a perfect square? Well, I'm going to take these steps. I'm going to go from here to here. This 16x was the same as x plus, well, let's see, that was, I had to add it to itself, so I had to half it. So the 4 and the 4 gives me that. So I'm going to take this number, and I'm going to, and I said this before, I'm going to half it, square it. I took half of 8, I got 4, and when I squared it, I get 16. That was my missing number here. You're going to see this come into play with circles big time. Now, when I put a 16 there, I was able to get a perfect square. Do another one. I will. X squared plus 20x. What number do I need here to make a perfect square? All right, I'm going to look at the coefficient of the x term. I'm going to half it and then square it. What's half of this?
10.
Squared. Now square it.
100.
100. So I'm going to make this 100 because now I can say this is a perfect square. And I can write it as x plus 10 squared. That's going to help me with my circles. And as you can also see, the half it is what lays in here. And then when I multiply them by each other, I get that. Okay, good. Let's apply it now. Let's apply it. I'm good. I'm good. All right, so I need to, here's some verbiage. I need to get the x's together. X squared minus 4x.
Aaron, let me know down below. We're gonna like hit the streets to see if we can get some more content, bro. That's a good jump right there, dude. Gotta jump this one too.
All right,
Let's
got-
go. Can
they
we get
got
up this?
bro and dude in that conversation. All right, bro.
Right down these stairs, or do I jump?
Yep, that was Jesse. All right, so I got my x terms together. Yes, I'm gonna get my y terms together. There's the y squared minus 20y. Yes, and I'm gonna say negative 68. Get rid of that. Go over on that side. I want you over there right now. All right. Complete the square. Half this and square it. What do I have to add?
Four.
Well, if I add 4 to this side, I have to add 4 to that side. So that's now negative 64. Half it and square it.
100.
100. So I'm now going to add 100 over here as well. That's going to give me a positive 36. Nice. All right. So by completing the squares, I now made this x minus 2 squared. That was the half it. Yeah. Plus y minus 10 squared equals 36. Center. They want me to identify it. The center is x minus what? 2. Y minus what? 10. The radius is going to be 6. Nice. And I'm going to throw this statement out. That looks so easy when I lead it and do a lot of the work. It does. But what did we do? We did over here. We grouped the x terms. We grouped the y terms. Cha-ching, cha-ching. We moved the constant term over to the other side. We sent it to the other side. Okay. Completed the squares. What I added to one side, I had to add to the other. And then I identified, big word. All right, let's see what we have. Number 5, that's all you. I'm going to pause the recording. I'm going to give you a couple minutes.
Yeah.
That's all right.
This meeting is.
Uh-oh. We're getting back to taking a look at it. I hope you got into some conversation in the breakout rooms. And let's see. I did a half it and square it. I added 25. A half it and square it. I added 4. Now, remember, this is going to become x plus 5 squared. So when I go to find my center, it's negative 5 because this was x minus h. Y plus 2 squared. My center, this is going to be negative 2 because it was y minus k. And then finally, that's the square root. Hopefully that didn't catch any of you off guard, that becomes the square root of 8. Cool beans, good, bad?
Good.
Okay. I'm going to the grocery store after class and I'm going to use this in the grocery store. Not sure how yet, but I'm going to use it. Yeah. Number 6. I don't think you got a chance to look at it, but if you want to follow along, got my x terms together, x squared and negative 3x. I did the y terms, y squared and negative 12y. And I sent that bad boy over there. Half of negative 3, I did the half of negative 3 is negative 3 halves. And when I squared that, I got 9/4. I'm not afraid of a fraction. Bring them on. half it, -6, squared is 36. So I add 9/4, I add 36. What was the half it here? That's what goes into parentheses. X minus 3/2. Y minus 6. I combined those two and got -140 over 4. And I changed 36 into 144. Oh yeah, that's 4 over 4, that's 1. So for this problem, my center would be 3/2, comma 6. My radius would equal 1. All right. These 75-minute classes are a lot of fun, especially at 8 o'clock in the morning. I love it. Just a reminder, I'm gonna stop the recording.